So very nice to meet you all. My name is May Walter. I'm the CTO and co-founder of HUD, and along with this awesome group of people, we're building a runtime code sensor that helps agents get the context they need from production in order to generate code that actually works in complex environment and not just vibe code. And I wanted to tell you a bit more about the MCP server that we built, but wanted to start with why we're actually building it. So let's do a quick show of hand. Who's using Cursor, Copilot, Claude, or some other coding agents? Oh, wow, that's great. Who's using at least one MCP server, as they do? Okay. Who built one so far? Okay, don't tell anyone the trailer, the spoilers. But hopefully we'll go over why we need them, why are they helpful, and how do we actually build one of those. So what triggered us to build our MCP server is about connecting Cursor to what's going on, Cursor or any other coding agent, to what is actually going on in reality. When we are looking at our code base as senior engineers, we want to understand what happens a lot, what fails, what isn't even invoked at all and is some legacy system. And all of that context is not available to those tools today. And therefore, it is very hard to expect them to be able to generate code that actually works. And being able to gather that context will help us get better results from our agents. For example, if I just heard from my customer support that users cannot delete posts in my blog systems, and I will ask Cursor why, obviously I will get an answer, because those agents never say, I actually don't know, right? They're going to say something like, oh, there could be several reasons. It could be a permission issue. Maybe it's a connection issue. Maybe it's something with the database. Let's look at the code and try to guess what could go wrong. Where the main point here is that there could be several reasons. But I'm not interested in what could happen in theory. I'm interested in that thing that my customer just experienced and that the support engineers just asked me about. I want to know what exactly happened. And there can only be one reason that actually made it fail in reality. And that is what I am interested in right now. And those agents are not helpful at that, not because they are not good enough. It's because they lack that context. So today we're going to briefly go over what MCP is. This is not an introduction about that. Then we're going to talk about how to actually build one and about what is not there yet, because a lot of the time using AI for production systems sounds very, very awesome, and then it's hard to understand what is still missing. So we'll talk a little more about that as well. So MCP stands for Model Context Protocol, which basically means it's a protocol set by Anthropic around last November, meant to help standardize the way that we provide context for our models. And it was widely adopted. What you see here is the official documentation by Cursor and Windsurf and all of the other MCP clients that adopted it. Even last March, OpenAI, which is the competitor of Anthropic, embraced it as well, de facto declaring it as the official protocol that people are using. And the best thing that Anthropic did about that is they didn't just define some protocol in a blog post. They also built the infrastructure for us to be able to build on top of that. So we have the boilerplate SDKs that are built and provided to the community. They are all open source, and they help us build on top of it using the MCP protocol. As you can see here, Anthropic actually released those in a different repository called Model Context Protocol to make it easier for the community to contribute. And it's already risen and has a few thousand stars on the major runtimes. And these boilerplates are also coming with a debugger. So we're not just building some server that has no infrastructure. We can use the SDK to build the server in a way that makes sense in terms of the tools and resources that it exposes. And we can also use what is called MCP Inspector, which is the debugger, in order to understand how our server acts. Because a lot of the time, this is actually a big challenge, because when I'm building a context protocol server, I need to make sure that the agent actually gets what I want it to get. And These debuggers can be very helpful for that. So I can actually run MCP dev and link to my Python server or Node server or whatever and see how it behaves in action and ask, for example, if my tool is to get the endpoint performance breakdown, that's the name of the tool that I exposed, I can actually trigger it with specific inputs and get the answer that the agent would have gotten if it ran that exact query. But let's get practical. It's a bit complicated, so stay focused. I know it's been a long day. We import fast MCP, kind of like fast API, and then we define a name. It is very important that the name will be representative. And then we initialize it with that name and some dependencies, and that is basically it, which is pretty awesome, thanks to the work that Anthropic has done. And this is exposing the MCP server that we have, and then once we define that, it could be either stdio or SSE, so different methods to authenticate. Usually you would start with a local server because it's simpler. And then we can start exposing tools. The tools are basically our way to tell the agents what we can do for them. For example, you can see here that there's a tool called Get Endpoint Performance Breakdown, and we also define its description. It gets you the 10 slowest and the top 10 slowing functions invoked when the endpoint is called. And this is basically it. The whole decorator that you're seeing right there takes care of the whole heavy lifting part, and the agent will know that there's a tool called Get Endpoint Performance Breakdown. It will know that that is its description. We can also define the data schema so that it knows what inputs are needed, and I can start rolling with it. This is how it actually looks like in the inspector. What you can see here is that I'm connecting to my MCP server that runs locally, and then I can see the different resources, click on List Tools to see all the tools that are being exposed, and if I choose a specific tool, I can actually type in the different inputs and basically debug my server to see what reactions are going to get so that I don't have to go over through talking to Cursor or Claude or anything like that to see the input that my server is going to get, which is very, very convenient. And also pretty good for testing as well if we want that server to remain consistent. So it's alive. We have an MCP server. That's pretty cool. But something still doesn't add up. Why? Because when the support ticket is open, they say something like, users can't log in. But there is no function in my code called login for the user, right? There's an endpoint, and that endpoint actually maps out to some local functions. So the data doesn't really connect, and that is a really, really important thing to understand about those MCP servers, is that we have to make sure that our context fits the data model in which the agent is operating. For example, if we look at Cursor right here, the unit that he's looking at is a function. You can tag a specific function in a file that starts and ends in specific lines. So I have to be able to speak its language in order to provide him the context that he needs. But in production, those functions are slightly different than what is seen on my local computer. Especially if we're talking about interpreted languages like JavaScript or Python, we have local paths that could be different per user. We have webpacks and transpilation and other horrible, horrible things that happen to my code. There's bytecode for that loaders or compiled languages use, and there are specific branches that might act differently. So just being able to understand how that function behaves in production is not an easy task. And the MCP is stateless. So just being able to understand that this repo is the exact one that I'm trying to find is not a trivial ask either. So how can we match this production to code? Great questions. Great that you asked it. So we built what we call prod to code, which means that when our sensor is running in production in AWS, Azure, GCP, on-prem, whatever, it basically calculates what we call function identity. So a set of attributes that are unique to that specific function, and also the link to the different endpoint or event consumer. So this function, here are its attributes, and it is being invoked from getUser, sign-up endpoint. It is then passed to the backend, and then once the MCP server gets its own function identity from the local, it can say, hey, I'm seeing this function in the user's code. Please tell me more about it. It is being matched in real time, and then the agent can get the context around that function. It is done by two different mechanisms. One is the service identification, saying, hey, this part of the code base right here matches this application that I'm seeing in production. It could be a monorepo, and then subdirectories are being linked, and it can also be multiple repositories where we want to link them to the different applications that we have on our system, especially if we're talking about distributed systems that can have tens or hundreds or thousands of different applications. And we only want the context that the user actually cares about. The second part is the function identity. We use multiple mechanisms for that, a lot of understanding of how the runtime actually identifies those functions. And TreeSitter, if you're not familiar with that, it's a really awesome open source project built by GitHub that allows for AST, abstract syntax tree calculation. Specifically, the awesome thing about TreeSitter is that it runs incrementally, so it's very, very fast, and it allows you to understand how that function behaves across different runtimes. And then we can actually match the production functions to the local functions that Cursor is seeing without storing any of the code in our backend, which is something that we wanted to avoid for security reasons. So let's say we already had that one figured out. Now they can kiss, right? We have Cursor, we have the MCP server, we have the matching, everything is going great. Let's see. This is where it gets a little complicated. You click the settings button, then go to Cursor settings, and then we can set up our MCP servers. It seems that most of you have done similar things in the past. And once I define that server, I can enable it, and I can also see the different tools that it exposes for the system and manage those. We can see the different commands where the server is actually triggered, and we also have the workspace name key that we're seeing right here, which helps us with preserving the state. Once I open a specific window or repository, I link it to the right application, and now we have that key in order to make sure that we gather the right data that is really relevant for that. So we have a tool called Get Endpoint Production Context. It gets you the production context for the endpoint, filtered by the service name if needed. And we have the server running and configured, and we figured out the whole function identity thing, which was quite a challenge, and nothing happens. And I think that's a lot of what is frustrating around working with AI today, is that sometimes it doesn't work and you have no idea why, and at other times you get a response and it's not exactly what you asked. It's not failing, it's not an exception, but it's not that thing that I wanted. There's this iterative loop of trying to make sure that it actually fits our goals. And in this case, it did not. Why? Because Cursor and Claude never used our tools. And what we figured out eventually is that these names are not very appealing. Something that gets you endpoint production context, what does that even mean? What can I do with that? So we changed them, and we understood that it's not enough for this to work. We wanted to actually see what we need. So we changed them to Get Endpoint Error Breakdown. This title sounds like a small change, but it's very imminent, because instead of telling the agent what can be accessed through this tool, we explained what to do with it. You can get the functions with the highest error rates. This is why it's good for you. And all of a sudden, these tools started to be called more and more. And it sounds a little silly, but I really wanted to emphasize this, because this is what I think some people get wrong about MCP servers. And everyone's saying, yeah, it's not an API, it's an MCP server. And it's not very clear what that means. And this is what it means. Because when I am an agent, I don't want an API. I don't want to be exposed some data. I want to understand what are my tools and when can I use them. Think about it like You would talk to a person on your team, say like, hey, you can do this if you want to get the endpoints and the errors. You wouldn't explain to them, hey, go to the logs in order to get data that was retrieved from your application in production. No, you would say, if there's an issue, go to the logs and try to find out what happened. And it's really amazing how these small things really do matter still in those systems. And the second part that we did there was around the user rules. Rules can be defined to basically enhance the prompt and give more context about the way that you do things and how you want it to operate. You have user rules that are relevant for all of the repositories and all of the context that you're working with, and we have the project rules that are specific for that project. For example, if I have this application and it's built in Postgres, then I can tell and explain a little more about the architecture there or about the way that the tables are built to make it easier for the agent to generate code. And once that happened, we also added a rule that says, when making a change to a function, check its production context through HUD and make sure you're making the right change and that the change is production safe. We basically embedded the runtime context as a part of the software development lifecycle of that agent. So let's see a little bit more about how this looks like. The first scenario is the runtime context as I code. For example, let's say my prompt was change the batch endpoint to receive an optional parameter with the batch size. Pretty reasonable response. The first thing would be, okay, let's get the endpoint production context. And all of a sudden we're seeing that, oh, this endpoint is being called 350 million times a day. Maybe we should think about performance in a different way than we would have for just some other endpoint. Let's see the performance breakdown and the errors. And now the agent has that context on where time is being spent in this process, how often it's called, and it can take that into consideration when it decides how to generate the new task we had at hand. In this specific case, you would say, okay, add events. That's the batch processing main event. Let's look at that. And once I finish deploying, I can ask, can I deploy this to production? And now we can actually take the change set and compare it to how that code behaves in production. Again, these agents are going to do an amazing job in just generating net new code. That's why vibe coding is so awesome. But when we are looking at a change set and we want to understand if we can deploy it to production, we don't just want it to work. We want to make sure that there are no unintended consequences around the system, especially when that someone says, hey, I know it's Friday, but let's deploy it anyway. It shouldn't really affect anything. It seems okay. Can you just approve my PR, please? In theory, of course. Anyway, so when I ask myself, can I deploy this to production, I can actually analyze the change set and its potential impact around what I'm doing. I can see if there are critical endpoints that are involved and maybe require more thorough testing. I can see the key functions that are invoked and how impactful are they for that process. I can see what changed. For example, in this case, we added an optional batch size parameter, and I can analyze the safety of this change. We can see that it's backward compatible. We can see the error handling, the monitoring, and so on and so forth, and feel much better or not about our change depending on what happened. And these are things that when you think about them, they already happen today with humans. When we want to make a change in production, we usually look at what's going on there today and what might be impacted. And we have that engineer that's been around for ages that just looks at it and said, no, this is going to break that thing that you weren't even aware of. So we need to be able to embed that same context for our agents to be able to generate code. So that's one example. Second example would be for the production issue resolution cases, meaning we already have something that is going on in production. Software finds its creative ways to fail in production all the time, and we just want to understand what happened. So now I can ask the same question I asked at the beginning of the lecture, like, this endpoint is failing. Why? And it will say, oh, let's see. I'll call get endpoint error breakdown. The agent found the right tool for the job, which is this specific MCP tool. And then it says, okay, let's see the different contexts that happened, like inside that endpoint. Oh, now I can see, based on that production context, that these are the main functions, and create session is actually failing with a Mongo server selection error. So we have the business error, which is that specific init endpoint that failed, but we can nail it down to a function, throwing in an exception, and connect it to what Cursor is already aware of, which is your local code base. And now it can actually help you solve what's going on in production. And being able to bridge that gap between the production and the code base was the thing that was missing in order to be able to do that, because it's quite ironic that when you're deploying new code, you're using all these tools, and then when there's a bug, we're still all alone, chasing bugs, trying to understand what happens in the logs, trying to add some more logs and wait for it to be reproduced. Makes no sense. And once we understand where the issue stemmed for, we can actually fix it using those tools, or not, depending on how we want to work. So again, if you're looking at the MCP resources, they can say things like how to bake a cake or how to bake bread. And these are tools that are just out there for you to use. But we still need the rules in order to understand that if you're hungry, you want to bake something. And without that piece, it is very, very hard to connect the fact that I am hungry to this bake a cake menu. Maybe I want to order in, right? And now they can actually kiss and get to that flow where we want to build a feature. When you build a feature, take the runtime context into consideration. There's this MCP server with the tool that says ho. If you want runtime context, there it is. And now we can actually have a process. Some gotchas that we got along the way before building this and getting to a point where it's really used in hundreds of different instances a day. First of all, you have to know why you build this. There are a lot of different things that could be cool to build into the agentic flows, a lot of context that might be relevant, but there's a big question around what it is that you need and why do you think that the agent is going to need it in order to perform that task that you want from them. In our context, it was trying to get that runtime context into the agent because we believe that it's going to need it in order to solve bugs and in order to build features in complex systems. Second part is to match the context to what the client's data schema is. If we're talking about code, it would be the functions. If we're talking about ChatGPT or anything like that, it would be the URLs that it can then get or anything like that, just to make sure that it can actually connect the context that you're providing to the data schema that it works with. I think Toby from Shopify said it pretty well. They called it, he likes the term context engineering and not prompt engineering because it describes the core skill, providing all the context for the task to be plausibly solvable by an LLM. If it doesn't have the context, maybe it's not plausibly solvable. Maybe if ChatGPT cannot access the live traffic data, it cannot help me navigate from here to the main city. It's not because it's stupid. We're not just waiting for the models to get better. They're just blind to the context that I need. Maybe if they don't have my contact list, they can't email Irene about that meeting that I wanted to push. And that's fine. And I think that's a lot of what we're seeing today is around finding that context and engineering it into the processes. Because we're building processes, not just tools. Trying to understand how do we envision the agent actually using that context as a part of what it's doing end to end. Bottom line. MCPs are really cool. It's a really cool protocol. I think it's amazing that Anthropic really took a stab at that, saying like, okay, this is something that the world is going to need. Let's build the infrastructure so that we don't have to reinvent the wheel all the time. But it is still a protocol. It is fairly new, and it changes all the time. So we need to understand that our expectations should be adapted to that. And context matters. Better context will likely yield a better outcome. The rules and the guidelines matter a lot, just to make sure that that thing is well defined. And if you define what you need, you're going to get a better result. And my personal opinion, and from what we're seeing at HUD and from what we're seeing from our customers who are also building at scale, is that doing that extra mile is worth it in setup and configuration. If you just move from PyCharm or VS Code to Cursor, it's going to be cool. But if you actually spend a little more time in gathering the right context and setting the right rules in place, the outcome is going to be much, much better and much more consistent around the different engineering organizations that you work with. And that also comes to place in the interfaces themselves to make it easier for you to build. And we can probably have another talk just around that topic, but hopefully I gave you some practical tools that you can start using and playing around with. It really is not that big of a deal to build an MCP server. A lot of the security constraints and the infrastructure that you might be facing could be solved with 30 minutes of vibe coding, one small server just to try it out. It is surprisingly elegant. About the future, I don't know. It's a really big question. I'd love to hear your thoughts around here or later on LinkedIn, but maybe we're going to see this MCP thing grow into a real thing. And thank you for your time.